All right, well, welcome back. We're going to look at the chain rule a little bit more. We'll get into some more harder problems here. We'll look at some rational functions. So let's start something a little different today. Um, we're going to call our function g, okay, and variable t. It doesn't always have to be y and x. So we'll do t here. And we have a little function, 3 over 4t minus 1 squared. Now we don't have a function of t on top, we just got a 3, a constant. So we're going to use a strategy. We're going to rewrite this. Okay, so we'll say g of t is equal to 3 times 4t minus 1 to the negative 2. All right, so our inside function, we can still call it u. That's okay. U is going to equal that 4t minus 1. Nice, simple function. See the du, instead of x, we'll just do dt, and that's equal to 4. Now, our inner function, well, we'll go ahead and call it y for right now, okay, is equal to 3u to the negative 2. See, it's 3 times u to the negative 2. So we take this dy du, and it looks pretty straightforward. We got negative 6 u, subtract 1 from negative 2, and we get negative 3. We got a nice little function going here. Let me scroll down. All right, now putting this together, we'll just write it g prime of t. So that's the derivative. I know writing that dy dx has been a little tedious at times, but here we go. We'll just write g prime of t, this derivative here. So here's this. So we got negative 6. I'm going to replace the inner function now. So there's that 4t minus 1 to the negative 3 times 4. Nice simple little derivative. Writing that out, g of t is equal to negative 24 4t minus 1 to the negative 3. Now we could make this a little prettier by resolving this negative exponent, and the derivative then would be, so we can resolve that easy enough by just putting the 4t minus 1 in the denominator. That's what that negative exponent means. So it really means that that 4t minus 1 cubed is down there. And there we have our derivative. Oops, sorry about that. Didn't mean for that to pop up. So started with 3 over 4t minus 1 squared. Took the inner function. Here's the outer function. Took their derivatives and then put them together. Okay. Now then, let's do one more function here. Okay. Let me get a little bit more room here. Okay, we'll start with this one with y. Y is equal to 5 over 4 x squared minus 1 cubed. Okay? Now how might we write this? We got this 5 and this 4 here. Well, not to be undone. 5/4 is a perfectly fine coefficient. So we'll just put that out there. X squared minus 1. Again, this was from the denominator, so we're going to make that exponent a negative exponent. And then just apply our rules. So inner function, the outer function is 5/4 u. See, we're just going to put the constant with our u here. Now the derivative well, dy du, it's not with respect to x yet. Okay, we take that exponent, multiply by what's in front, so that's negative 15/4. You subtract 1, negative 3 minus 1 is negative 4. Okay, over here du dx is equal to 2x. Okay, let's put this together now. Okay, so our y prime is equal to negative 15 over 4 x squared minus 1 to the negative 4 times 2x. Okay, now then we have a negative 15 in the denominator. This 2x is in, I'm sorry, this negative 15 is in the numerator, the 2x is in the numerator, 4 is in the denominator, and this negative exponent makes this in the denominator. So let's put the parts where they belong. So I got negative 30x all over 4 x squared minus 1 to the 4th power. I can do one more simplification since there's a common factor of 2 between the 30 and the 4. Notice this is all one term. Okay, just two factors multiplied together. It's this times all of this. So I can divide out the 2. I've got negative 15 over 2 x squared minus 1 to the 4th power. Okay. Now, the next example I have is a little more complicated and it's probably going to run over my time. So I'm going to wait for that for the next part and stop this for now. Okay, see you in the next video.